Hello friends, my name is Riya Satam and I am a student of BE Computer. My project name is face recognition. So this is the word, actually there are two words, face recognition and detection. What is the main difference between it? So face detection, it is the term which is used to it is a system which is able to identify that there is a human face present in an image or not. But face recognition can confirm the identity. It is therefore used to control the access to sensitive areas. Now the algorithm which I have used in face recognition is Lbph algorithm. What is this algorithm? So Lbph stands for local binary pattern histogram. So this algorithm, it is the face recognition which is used to recognize the face of a person. It is used to recognize the face from both from front face and from the side face of a particular person. Now we can see every image is being divided in a format of matrix. As you can see, this image is also divided in the form of matrix. That is nothing but the rows and columns. So basic component of an image is the pixel. That means an image is made up of set of pixels. Similarly, I've taken the example of this image which represents a smiley, and it has been divided into the small boxes which is nothing but the pixels, and by placing them side by side we get a complete image. So a single pixel is considered to be the least possible information in an image, and for every image the value of pixels ranges from 0 to 255. Now in this image there are 32 pixels wide and 32 pixels height, which when we multiply we get the result as 1024, which is nothing but the total number of pixels in the image. And each pixel is composed of three values, that is RGB, which stands for red, green and blue colors. So this combination of these three basic colors will create all these colors here which are present in this image. Now as we got to know what is image and how it has been divided into pixels, now we'll come on to our main algorithm, that is Lbph. Now for example, I have taken this matrix. This is a matrix which represents the piece of the image. Here in this matrix there are 3 rows and 3 columns. That means the total number of pixels here are 9. Now let's select a central pixel whose value is 8, and we'll apply a condition for it. So that condition defines that if the value of other pixels is greater than or equal to 8, the result will show as 1, otherwise the result will be 0. That is, if the value of the pixel is less than 8, the result should give me as 0. Now after applying my condition, my matrix will look like this, which you can see on the right hand side of the screen. So I can explain as the first row, first pixel has value 12, which is greater than 8. So my result can come to be 1. Similarly, the second row, first pixel value is 5, which is less than 8. So my result is 0. So the basic calculation of this algorithm is to apply this condition and select the center element of the matrix. Now after applying this condition, I get a binary value, which is nothing but 111000010 in this case. So how do we get this binary values? By applying this algorithm, we start applying the condition. From where? That is nothing but from the top left corner, and it goes up to the first element of the second row. It generally makes up a circle like this. You can see in the picture on the right hand side of the matrix. So after when we get this binary value, we convert it into a decimal value. So the decimal value what we get here is 226, which indicates that all these pixels around the central value are equal to 226. Now, as this algorithm is robust when it comes to lightning. So if we put a flashlight on the image, the value of the pixels will increase, and higher the value, brighter is the image. For this reason, this algorithm is good, gives a good result in light and dark images. Because when image becomes lighter or darker, all the pixels in the neighborhood will be changed. This now the matrix which is shown on the screen, it is the same matrix, but only difference is that we are putting a light on the image. So after putting the light on this image, the matrix looks like this, which means the values of the pixels have been increased. Now again we have applied the same condition which initially we had applied. Here also we are taking the center element, but now initially the center element was 8, but now the center pixel is 38. The condition is the same, that if the value of the pixel is greater than or equal to 38, then the result should be 1, otherwise the result should be 0. So after applying the condition, we get a binary value, the same binary value, that is 111, 000 and 10. Now this was the part of matrix. Now our next step is to create a histogram. This is a concept of statistics which will count how many times each color appears in each square. So the representation you can see on the right hand side of my screen, the bar type representation, that is the representation of a histogram. So you can take an example that if the value is 110 which appears 50 times, the bar like this will be created, which you can see on the screen with the size of equal to 50. Now, if 201 appears 110 times, and the other bar, then the other bar will be created in this histogram with the size equal to 100. So, based on the comparison of the histograms, algorithm will be able to identify the edges and also the corners of the images. So, in short, this algorithm tells us which histogram represents borders and which histogram represents the person's main features, such as color of the eye, shape of the mouth, and so on. So this was the basic concept behind this algorithm, which is based on the creation and comparison of the histogram. Now, since we got to know what is Lbph algorithm, we will go on to our next part of this program, that is the coding part. So, yeah, you can see this code. This is a Python code which I have made for recognizing a face. So this code is basically divided into three parts. Generate this data set, train the classifier and save it, and third step is detect the face and name if it is already stored in our dataset or not. For that, we have to just import some libraries and create a function for it. As we can see, I've created a generate dataset function. For that, I've used a cascade classifier named HarCascade so that it can detect my front face and side face also. I have also defined a function named faceCrop to crop my face in a rectangular part, and it only detects my face part, not my other body parts. I have converted my BGR color to a grayscale color by using this method. Then I've used this classifier, face classifier. I have given the condition, if condition, as if there is an empty, then it will return as none, otherwise it will crop my image. Next, I've opened the camera by giving the command as video capture. Since I'm using a inbuilt camera, so I have to give 0. If it is an external camera, you can give 1 or -1. Then I've given id equals to 1. Now what is this id? So id is the image of an authorized person. For that, I will show you my data set. Yeah. So this is my data set. Here you can see user.1.1, user.1.2. So this 1 represents the ID of a one authorized person. Next comes my image ID. Image ID equals to 0. 0 I have given because initially there are no images. Now what is this image ID? So you can see in my data set this user.1.3, user.1.4. So this 3, 4, 5 which goes on increasing. Means It is nothing but the image of a particular person in different angles which I've taken, which goes on incrementing till 200 since I've given the limit as 200. Then I've used an infinite loop which captures my images, and then it goes on increasing my image ID from 1 till 200. Next, I've showed the IAmShow function has been used to show my output. The next step here is I have used wait key equals to 13. Now what is this 13? 13 is the basically it is the ASCII character of enter, which means if if I'm generating my data set, that time if I want only 50 images of a particular person, then I have to just press an enter when the count goes 50. If I want 100, I have to press 100 when the count comes to 100. I have to just press an enter key. Or else, if I'm not pressing enter key, then by default, automatically it will take 200 images and then it will stop generating my dataset. As I've given the limit as 200, it will stop after 200. The count goes to 200. Then I have just released my camera, destroyed all my windows, and give the it will give my the message as collecting samples is been completed. Now here we complete our first step, that is to generate dataset. Next step is to train the classifier. For training the classifier, we have to import some libraries that are NumPy, PIL, OS, and CV2. PIL stands for Python Imaging Library. From Python Imaging Library, we are importing image library. OS stands for operating system, and CV2, as we know, that is the important library for face detection. Now, next, I've created a function named train classifier, and I've passed my data set to data directory. Then I've created a list for giving the path where my data has been stored. I've created an empty list for faces and IDs. Then I've used a for loop, and I've passed my image to it. Now this is the command we can to convert a BGR image to grayscale image. There are actually two methods where we can convert a BGR image to a grayscale image. First method, as I have told you, you can see it over here in this line of command. This is the first method where you can convert a BGR image to a grayscale image, and this is the second method to convert BGR to a grayscale image. Then I've an array, NumPy array. I've given a path to it. I've appended faces and IDs list. I've then created a classifier, and I've passed this classifier a face Lbph face recognizer. As I've explained you initially what Lbph is, so this is the use where we have used this algorithm. Lbph nothing but histogram, local binary pattern histogram. Then I've trained my faces and IDs. I have written the output, it will show as classifier.xml. Then I've called this function and passed a data to it. Now, after executing this program, we will get a classifier XML file in my program. You can see over here, this is a file which is XML document. You can see over here, which has been trained after using this program. Now my next step is to detect the face and name if it is already stored in my dataset or not. For the same, I have used the same directory or same libraries being used to detect a face. The next step is to draw a boundary around my image. For that, I've created a function named drawBoundary, and I've passed my image classifier, scaling factor, minimum neighbors, color, text, and classifier. Here also I've converted my grayscale image to my BGR image to grayscale image. Then I've used a classifier. Next step is to create a rectangle. The key point over here is while when we are using this rectangle function, we have to pass a real image, not the grayscale image, because we want our output to be in a real image. Means the rectangle should be present in my real image and not in my grayscale image. Then I've used this function to predict the gray image. Now while using the predict function, I've passed a grayscale image. Why grayscale image? Because when we want to predict what is the output, it will go and compare with the image which is present in my data set, which is nothing but the grayscale image. Next step is to define the confidence. For that, I've used the formula that is 100 into 1 minus spread divided by 300. This formula will give me the confidence, and I've used a next condition, if condition, where if the confidence is greater than 70, then it will enter the loop and it will give me, if id equals to 1, it will give the text as Riya, otherwise it will id equals to 2, then it will give the text as Ritesh. Elsewhere, it will give the output. It will give the output as unknown, that too in red color because I've used a 255 over here. This 00255 is nothing but BGR, which I have explained in the PPT. It is nothing but the RGB, sorry, RGB. So I've given a red color over here, which will give me the color that is red. Then I've returned an image to it. Now next I will capture my video over here. That is, I will open the camera and I've given the loop to capture the image. I've called the draw boundary function and I've passed my real image over here. Then I've passed this face cascade classifier which I've defined over here. That is face cascade is equals to cv2 dot face cascade classifier r cascade frontal face default dot xml. Then I've given the scaling factor. This is the minimum neighbors, that is 6. Now what is this minimum neighbors? So minimum neighbors defines the minimum distance between the rectangles. Means during my execution, if there are multiple faces, it will create multiple rectangles for each face. And the distance between these rectangles is given is nothing but the minimum neighbors, which I have given as 6. This is the color. I have given a white color, so I have used all BGR, that is blue, green and red. Then it will give the title as face, and this is the CLF. It is nothing but the classifier which I have defined over here as face.lbph face recognizer, where I've used the algorithm named Lbph again. Then it will show the result as face detection, where I've passed the image. Then once I press the enter key, my execution will stop over there and it will come out of the loop. My camera will be released and it will destroy the window. Now we will see the output of this. Yes. So you can see that my face has been detected. You can see a rectangle has been created around my face, and also it is printing my name over this rectangle, that is Riya. This clearly tells me that my program is working, it has been executing properly, and it is not only detecting my face but also it is recognizing who the person is by giving the name of the particular person. Now you can see it is recognizing me, and if there is no data set, then in the place of Riya, it will show as unknown in red colors. Now, since my program is working, you can see it's properly working. So I'll just stop the execution by just pressing enter key. Now this was a simple program I've done using a Python code. Now next there is another thing I've used is GUI face recognizer. That is using the same program but by GUI. What is GUI? GUI stands for Graphic User Interface. Now using GUI in Python, or sorry, in Jupyter library, we have to import some libraries which is nothing but tkinter. Tkinter is the application of GUI which is used in Python, and it is an inbuilt application, inbuilt library of Python. So we just have to import it. I've also the same I've done. I've imported tkinter and I've imported message box. This message box will give me a message after doing a particular execution. Then I've imported a NumPy library, PI library, OS library, and CV2 library as I've done in the basic Python program. The code here is the same as what it was initially for basic Python program. The only difference is that we have to create a window, which I've created using a tkinter. I've given the title as face recognition system. Then the next window will give me, you can see the output over here. This is the window which I've created. The title has been given as face recognition system. Next is the name. It will take the input as name, which I have declared over here. Yeah, I have given the label. You can see label window as name. Font is Algerian. Font size is 20. Column is 0 and row is 0. Because this is my first text, so column and row is 0. Now this next command is for my dialog box, this empty dialog box, which will take the input from the user. For that I've used the tk entry window. Width is 50 and bd breadth is 5. This is a column 1 because column 0 represents name, column 1 represents my this dialog box, and it is the same row, so 0. Similarly, I've used the label for age and address. Then I've defined the train classifier. The function is the same which I've used in the simple Python program. Only the difference is that in Python program, when I'm using train classifier, you can see over here, while training the classifier, I've passed a data directory over here, and then when I've called the function, I've passed a data. Data is nothing but the name of my data set. Here, I only have to pass the path where my data has been stored. Now, where is I've just copy pasted the path. You can see over here, this file name is data, and my data has been stored over here. So I've just copy pasted this path, and you can see I've passed it to data directory. So this is a basic difference between the two GUI and the basic Python program. Then the remaining code is the same as I have explained initially. Next is I have created a button for it. I've passed a window. The button tells us the training. When we will, you can see in this output, this training button is there. I've given a font size to it, font which I've used is Algerian, a background color, foreground color. Then I've given a command as train classifier. Here you can see I've called the train classifier method, which means when I click on the button, it will start training the classifier and it will go on to my this function and it will execute this part of my function. Next function is to detect the faces. This also remains the same, the code is same as I've explained initially for my normal Python program. Again, I've created a button which is named as detect the faces. Again, the same font size, font color, and background color, foreground color. And I've given command as detect faces, which means when I press on this button, the function will go to detect faces function, which is present over here, and it will start the execution according to this code. The third part is to generate dataset. I've used the same code to generate my dataset. You can see over here, it's the same code. Only I have to just create a button again over here. I have to give the name for the text as generate dataset, and I have to just give the command as generate dataset, which means the function name, and will go to my function where over here and will start executing the executing the function according to this code. And then I've created a geometry 800 by 200. We can change this according to our need, and then I've used the main loop to exit my window. Now you can see this window. I will also show the execution of this window. Now after pressing this training button, it will start training, and once it is completed with the training of dataset, it will give the message as training dataset is completed. Okay, you can see this dataset has been trained over here. You can see this classifier, which means my dataset has been trained. Now next step is to detect face. I will click on this button and it will again show me the output window, which will start detecting a face. Yes guys, you can see that this window has been generated, and it is started to detect my face and also recognize who the person is. Now I'll press the enter key to exit my window. Next is to generate dataset. This is the important thing, because here we need to give the input for my name. I'll give the input as name. I'll give age of my input as age, name, and address. Once I have given this input, it will start generating dataset. Also, I've given the condition that if any one of this field is not completed, it will give the image output as fill the details. You can see when address has been not filled, when I click on it, it will give me the message, please provide complete details of users. Okay, so I have to give the complete details. You can see I've given my complete details, and now I click on generate dataset. So now you will see a window. Yes, on the output you can see window, and it is also showing me the count, how much it goes, means how many picture images are being captured of mine. And once it is completed with generating dataset, it will give me result as generating dataset is completed. Okay, so my program is working very good, and yeah, that is this is the end of the program, and that's all. Thank you guys for listening to me. Thank you.